I'm joining you today from the soon to close down Cobalt office. We are going fully into the cloud as a business as well. It's been an interesting year in 2020. And today we're going to be covering our attack and defense series, which is real life attack protection stories based on our experiences with clients and in the industry. Episode number 2, we did one earlier this fall on compromise and security. And today we're going to be talking about protecting the cloud. So we're going to dive into some war stories and lessons learned. So thank you very much for joining today, and hopefully you learned some stuff. If you have any questions as we go, please feel free to post them to the chat window. Just to be aware, we are recording today's session for posterity and reposting. So I'll start with a little bit about myself. My name is Michael Argast. I'm the founder and CEO of Cobalt Information Security. I've been in business for just over 2 years. And myself, I have a background of over 20 years in information security with a career that spans technical operations, consulting, leadership, as well as sales. So I've had roles in the past running global teams at Sophos, regional teams at TELUS, and now at Cobalt. Very well connected here locally to a variety of strong security groups, including ISACA and the Provincial Security Advisory Committee that provides advice to the province of BC. I've done a whole bunch of press. Most recently, we had some great coverage in the Globe and Mail, which was fantastic. And when I'm not online helping our customers be more secure, I try to get offline. And so I'm into things like camping and snowboarding. For our agenda today, we're going to start with a baseline, really helping organizations understand the shared responsibility model, which is something that AWS put out a number of years ago to help organizations understand what the IaaS or infrastructure providers are responsible for versus the clients of those platforms. It's really good to give a good foundation of understanding where security responsibilities start and stop. Then I'm going to get into a number of different war stories. I've given them fun little titles: leaky buckets, creeping credentials, devs are human too, and a couple SaaS stories looking outside of the IaaS kind of scenarios. Then I'm going to provide some summary of our recommendations and how Cobalt helps. The shared responsibility model outlines the difference of responsibilities between the cloud provider, in this example, AWS, but this also applies to Azure or GCP, and the client. This is a little bit fuzzier today than it has been in the past because increasingly the cloud providers are also starting to provide services up into the stack. So you can get Lambda services from AWS, security application services, those sorts of things, which show up further up model. But when you're buying base compute and storage from your cloud providers, it's important to understand kind of what they're responsible for and what you're responsible for. So typically the cloud providers are responsible for everything up into the kind of interface that you have with their service. So they're responsible for the hardware, physical security, they're responsible for hypervisor security, making sure that their infrastructure is available. They're responsible for the security of their compute and storage, if they provide database services and networking, right? So they're responsible for kind of the security of the underlying layer. Doesn't mean that there haven't been issues in the past in some of those elements. We're not diving into them today because those issues have largely been in the past rather than recent. But generally, you can trust that your cloud provider is going to be taking care of that lower level of security on your behalf. And then the client is responsible for the security of their application stack and everything that builds on top of that, right? So this is things like the client-side data, making sure that's encrypted, that it's being protected. Server-side encryption, so for example, if you're running EC2 instances or Azure instances, that you're responsible for encrypting the data within those instances, networking traffic within your VPCs, your operating system, right? So if you're deploying containers, those containers aren't being provided by Amazon, they're being provided by some other provider. It could be Docker or something, or part of a Kubernetes library that you've taken out. So these things you're responsible for ensuring the security of those, your network, your firewall configuration, your platform, your application layer, identity and access management, which is a big one, and generally your customer data. So you're responsible for everything above that base layer. And often where organizations get a little bit fuzzy, not so much on the technical team side, but on the management team side, is they get confused about where those layers of responsibility lie. This can get even more complex when you start bringing in middleware providers or PaaS providers like Heroku and stuff that actually will take responsibility for a lot more of the layers and give you a very focused area of responsibility. So it's important to just understand kind of where those layers of responsibility lie. So first, I'm going to talk kind of fairly generically about one of the most common forms of breach that we see on the in cloud providers, which is the cloud S3 buckets with too global of permissions, right? And so, I want to talk a little bit about why this happens and how this happens and how you can protect yourself. So permissions generally have been one of these things that are hard. And so when you're building software, when you're installing applications, one of the things, whether you're an IT person or a dev, people tend to fall into a habit of is it's not working, right? I can't get application A to connect to data bucket B. I can't figure out why it's not working. And so I'm going to start off by just like opening all the doors because this is a test environment and I'm not too worried about it. And so I've got my S3 bucket, I've set it up, I've put some test data in it, and it can't connect to my application for some reason. So I start changing and opening up the permissions to allow for global access. And it could have been a permissions issue at the early stage that prevented you from allowing that access or something else, but you've made your permissions change and you've done it too broadly. And that happens all the time, right? This is kind of a classic IT sysadmin type of troubleshooting approach. So it's in your test environment, so you forget about it, you don't worry about it. And then eventually that same bucket gets migrated from tests to prod and stops holding just test data and starts holding production data. And so now you have this globally readable bucket out there in production storing sensitive data. And this is a pattern we've seen again and again and again, unfortunately, in the cloud. It's important to understand, like, when you're looking at these data breaches and you read about them on the internet, it's like, well, who would ever set a globally protected bucket, a globally accessible bucket out there on the internet? Nobody intended for this to happen. It wasn't like they thought about it and they designed their bucket to be globally accessible when they put their design into prod. It's much more, they were troubleshooting a problem. They didn't realize that nobody was going to ever go back and clean up that security tech debt. And so, maybe it was one person who deployed it and somebody else who moved it to prod and there wasn't good communications, but this happens again and again. The other challenge is, if this were to happen inside your data center, the odds are nobody's ever going to find it. It's just one of those things that's kind of behind your firewall and your WAF and all this kind of stuff. But out there on the internet and the cloud, there's a lot of automated scanners that will scan the entire AWS address space looking for globally readable buckets. And it'll start slurping out the data and seeing what's in there that's interesting, then you have a data breach. So it's important to realize that a small trivial mistake like this can actually have these cascading consequences. And so there's a number of things that you can do to protect yourself against this. One of them is making sure that you're actually paying very close attention to permissions and auditing as you're migrating to prod, but also once you're in prod, that you understand if there are permissions that are too permissive and allowing access to a variety of different things that you didn't intend, right? So it's not just the application that can access that bucket, but anybody out there on the internet. So that's kind of one obvious thing that you can be doing. The other is just kind of talking to your team and talking about this process of like, how are you troubleshooting these problems? How are you making sure that, as you're testing and deploying software, that you're not being too permissive, that you actually are reviewing this. So this is a classic problem. It's actually existed basically forever on the internet. If you've ever managed a Linux box or a Unix box, classically, when you're installing software, permissions are often an issue because software likes open permissions, and then you got to figure out how to lock it down properly. And a lot of people will just make everything universally readable, which again, not a problem in your local file directory as much, but it can be a problem when you're out there in the cloud. So I'm going to start my first poll, and the question that we have today is, what cloud services are you using? And you can choose multiple cloud services in this case. So maybe you're using one of the big IaaS providers, maybe using a PaaS provider, maybe using SaaS providers. You may be using a combination of these things. So take a moment to answer. We've got 4 attendees who've voted so far. We'll give another 30 seconds or so for everybody else to attend. Okay, I think we're pretty good now. I'm going to share the results. All right, so a lot of people are using AWS, Azure, GCP. I think people just voted. I think that it wasn't, you got a radio button rather than a checkbox. We've got people 65 and one the clouds here, which is fantastic. The only one that I've spoken to in 12 months that actually has no cloud services anywhere in your organization. So what we see typically in organizations is that most organizations tend to be a bit multi-cloud. And what I mean by this is they may have AWS services, they'll use a variety of SaaS platforms. You know, especially in the early stage of development, we see a lot of PaaS services in play to help organizations actually get their app code to market. Orchestration, once you get to 25, 30, 40 employees and you have a need to really provide scalable infrastructure, is very, very popular as well. And go back to my presentation. All right. So the next example that I want to give is an example that is also very common, not so much permissions, but identity and access management. So one of the most common errors that we see is management of credentials across systems. And as a result, the ability to laterally move once we compromise one environment to other environments. This use case was a large financial institution, and they deployed a WAF from a vendor that I will not name that was doing web application security as well as load balancing across their cloud environment. You know, one of the challenges with deploying the security modules is very often they are not designed to work well in a least permissions area. Sometimes the security vendors are some of the worst vendors this way. Not all of them, a lot of them are very good. And so this particular WAF was configured so that it had credentialized access to the entire environment. And the WAF itself, the web application firewall, was directly compromised, and it had both stored and access privileges, stored credentials and access privileges to that entire environment. So from a compromise of the WAF, they were then able to pivot to an S3 bucket, which was properly locked down, secured, had the right permissions and all this kind of stuff, using the WAF stored credentials, and were able to pull the data out of the S3 bucket, and the client had a data breach. And so the reason I brought up this particular story is it is a great specific example of IAM and credential management. And classically what I refer to as a sharp knives problem inside of AWS. It's not quite as bad in Azure and GCP, but basically the cloud providers give you a very strong set of tools around identity and access management, but not a lot of guidance in many cases as to what's good and what's bad. And so developers are generally pretty good at writing code, don't necessarily understand identity and access management to a granular degree. In fact, that's generally a common problem across a lot of security settings. And so, you know, they go out and they deploy their infrastructure. They haven't really thought through in a deep way how different elements of the infrastructure interconnect and how identity and access need to be provided between those communicating elements. Amazon and the other cloud providers aren't providing very clear, strong guidance. And so they tend to be overly broad in terms of providing permissions and credential access. And so once an attacker is able to penetrate some part of the environment, it becomes very easy for them to move laterally throughout the environment. And so, you know, one small weakness could be you've got a container that hasn't been updated or something. That container stores credentials or some sort of misused identity and access management privileges, and that leads to a compromise of the entire environment. And so being very tight on identity and access management helps reduce that risk. So thinking about not just the classic, you know, perimeter security for the things that are inside my network and outside my network in the cloud setting, but think of all of the elements of my network as being fundamentally untrusted to each other. Kind of a zero trust design allows us to properly implement IAM in a way that is the risk of a single compromised component leading to compromise of the entire environment in my data. I also wanted to take a moment here, just because it's timely and interesting, to briefly discuss the FireEye breach. I have the fire on this page to help me remind myself of this. And so a couple days ago, FireEye announced that they had been targeted by nation state, and they had had a bunch of their red tools popped, which is unfortunate. The red tools don't look particularly modern and sophisticated in that they take advantage of a bunch of vulnerabilities that are kind of a year, 2 years old. So as long as you're relatively current and patched, hopefully those red tools won't be used to harm a lot of people out there on the internet. I just want to say, like, breaches happen. It sucks, and FireEye, I'm sure, is very heavily by a whole bunch of sophisticated actors. You know, it's unfortunate this happened to them. They have a world-class team. I know a number of the people there personally, and you know, I'm sure that they probably had a much smaller breach than would have been experienced by other companies based on their security competencies. I know that from what I've read, the attackers were going after client data and were unable to get to that, and so probably had to settle for the red team tools that they were able to get their hands on. So just wanted to make a quick call out to FireEye and wish their team well through this difficult time. Next, the question for you and for everybody else is, how do you ensure secure code? And there's the multiple choice options. And so I'll walk through each of these options as you're kind of making up your mind to vote. So very commonly we hear peer reviews, which is kind of the, you know, somebody writes the code, somebody else checks the code. You see that very often in agile development processes. Manual security test cases, which is within our QA and test procedure, we're actually testing for specific security scenarios. SaaS is static testing of code. DAST, dynamic testing of code. Annual or periodic pen tests. Very often, if you're providing services to third parties, they're going to be asking for a copy of your annual pen test reports. There's black and gray box, which is an external perspective, and white box, which actually looks at your architecture and helps you assess that. Also, we'll combine SaaS and DAST testing, and bug bounty programs. And great to see we've got at least one person who is participating in bug bounty programs. The last one that we have on our list is scanning your code repositories for hard-coded credentials and secrets. And I'll talk about why that's important next. All right, I think we're good. Why don't we end that poll and share the results? And so we can see here, peer review is the most commonly used tool. And we see kind of about a third of the people using manual security test cases, SAST and DAST, as well as annual periodic white box pen tests. White box pen tests, in my experience, tend to be done less frequently by organizations because they are more expensive and more time consuming than black and gray box tests. Good chunk of people are doing black and gray box tests on a regular basis, which is good. One respondent was doing bug bounty programs, which is kind of an interesting challenge. You have to be relatively mature before you're typically taking this on, because you want to make sure you've got the low-hanging fruit cleaned up so you're not paying out all your money in bounties. And then scanning code repositories for hard-coded credentials and secrets. So great set of results there. And let's talk about why that last one is so important. So this is the creeping credentials stored token story. And so one of the challenges often you'll see for developers in writing code is that they have one application that needs to speak to another application, and that's an authenticated connection. And so rather than going through the complexity of going to a key store and requesting a key and then taking that key and using it to authenticate against that other application or that other API or whatever it is, they'll go, I'm just going to put that in my code. So they take the API key or whatever it is that they need to communicate with the third-party service or the other internal service, and they just hard-code it into their application. This is a shortcut. It's lazy. It's understandable because, you know, kind of going through that whole key exchange thing can be complicated for somebody who hasn't done it before. But it also comes with a significant risk. And so this particular story, an organization had developers that had hard-coded their tokens for the cloud service into their code. And then one of their junior devs who had access to their GitHub repository downloaded that code and uploaded it to a personal Git repository, which was public. So they were playing around with the code and were trying it out for different things. And we're kind of, you know, like every developer on the planet does, they were mixing and matching their puzzle pieces to do something else. But they had taken it and put that in a public Git repository. There are a lot of people out there who are doing lots of scanning of public Git repositories. They're looking for tokens. And so in this particular case, And criminals found this public Git repository, realized that there was a private token in that Git repository, and then used that private token to basically run up tens of thousands of dollars in cloud services on the original company's account, right? So this is an example of one of the risks that could be experienced by an organization that is inappropriately dealing with credentials stored within code. And so one of the things that Cobalt does is, we'll actually scan your Git repositories for stored credentials so that you're aware of them and you can remediate that before it becomes an issue. And that's a kind of a common thing that we recommend organizations undertake to reduce that kind of risk. My last worst story for today is kind of the devs are human too story. We have a ton of respect for developers. They're doing great and innovative things. One of the things that is true of developers, also true of security professionals, sometimes we're not great at following best practices. And so, there's risks that come with that. And so in this particular case, the organization in question had a very strongly secured hosted web application. So it was passing its pen test with flying colors. The front end door that was exposed to the internet via their AWS services was rock solid. And so the attackers realized this, they couldn't get it in the easy way. And so they pivoted, they targeted a developer, they phished them directly, doing some LinkedIn research to figure out who was developing for the team, compromised that developer's laptop with a piece of malware. They were then able to inject code into code that was on that developer's laptop being pushed into prod. And it got through the usual peer review process without being detected. So there was a backdoor then that was in their GitHub repository. And like many organizations these days, they had an automated build process which pulled the compromised code out of the repository into production, and that led to a backdoor that existed in their production environment for over 12 months. The big challenge in this case is they had no mechanism for detecting and monitoring that type of unexpected system access. They had done the right things to lock the door, but they hadn't done the right things to make sure that somebody was watching the door. And so as a result, a dev who was in theory very, very smart made a mistake that led to a compromise of the production system. So just to remember, devs especially really loathe running antivirus software because they think it slows down their build processes and other stuff like that. And everybody is human. We can be compromised through phishing and other types of attacks, social engineering. And so being aware that that is an attack vector that can be used to compromise your cloud is really important. The thing to know about this is attackers are smart. They will go, they'll try the easy thing first, right? So if I can rattle the front door and get in, they'll go that way. But if they can't get in through the front door, they'll find a side door. And in many cases, humans are the weak element. I like to say, if infrastructure is weak, then the attackers will attack the infrastructure because they can do that automated scans and that scale. But if infrastructure is strong, they'll go after people if they're weak, right? And so just to kind of realize that and have your defense in depth with both your infrastructure and your people. So my last question for our poll is, how secure are your developers? So if you were to look at your developers and their workstations, their laptops, how secure would you say that they are? And here's some things that can help you answer that. So are they running anti-malware on their development machines? Are they participating in your annual security awareness training? Are they using multi-factor authentication wherever they can? That's one that often developers are pretty good at. Although I have one particular client right now who will remain nameless, who I keep encouraging them not to use their AWS root credentials without MFA. Do they participate in any sort of regular security-related SDLC training? So this is, could be online, could be in person, where you train them on security best practices. Do they run as root on their dev machines, right? So classically, one of the things that we see a lot is they ignore the kind of classic, you shouldn't run as administrator or root on your dev machine, because that makes it easier for malware to compromise and exploit those machines. All right, we'll give it another couple seconds. We've got a good round of responses here. So let's end our poll. All right, so as you can see here, we've got 2/3 of organizations running anti-malware on their dev machines. That's probably about what I would expect. Only about half of them are participating in the annual security awareness training and phish testing. Either that's half of you are not running this at all in your organizations, or half of them are not participating. Multi-factor authentication wherever they can. There's kind of three key areas that I would consider are important for devs, especially. One is your cloud infrastructure. So any sort of authentication that's required to access that, to run systems using multi-factor there wherever you can. The second one is your GitHub repositories, your code repositories. Using MFA there can dramatically reduce the risk of a credential stuffing or compromise attack. And the third is their email, where if I can compromise a dev's email, that can be a point of entry for a lateral attack. SDLC training, this is interesting and it's a big challenge. You know, education is one of the most important things we can do, and teaching your coders new languages and stuff is great, but teaching them about security best practices with those languages is also very, very good. And sometimes language selection itself makes a difference. Like, don't write anything in C or C++ anymore. Use Rust because it's memory safe and stuff like that. And so, you know, making sure that your devs are up to speed on current best practices as it relates to secure development can dramatically reduce the risk of vulnerabilities being introduced into their code. And then not running as root on their dev machines, yeah, that's again really common. And then, of course, a lot of them regularly ignore security and IT policies. That's a lower number than I would expect, so that's good. All right, I'm going to stop sharing that poll, and we're going to provide a couple more tidbits and then wrap up. So last story is not an IaaS story, it's a SaaS story. And so classically, one of the questions that I often get asked is, you know, is my cloud more, is storing my data in the cloud more secure than if I were running my own data center locally? And the short answer is SaaS services can be more secure because there's no service for you to patch. The provider is responsible for securing the platform, especially if your provider has gone through things like EP.2 or is a certain scale so they can really invest in their security organization. But compromises do continuously happen on SaaS platforms. And the primary method that we see is credential stuffing. And credential stuffing, for those of you who aren't familiar, is reuse of credentials from one site where it's been compromised and trying it on a whole bunch of different sites where you may have an account. So people reuse passwords typically. So an example would be, you know, everybody is on, I don't know, let's call it LinkedIn. They had a big breach a couple years ago and they've reused their LinkedIn password on a bunch of different sites. The bad guys and criminals will take those credentials and they'll try them across a variety of different sites on the internet and see what they get access to. So this happens all the time. It's significantly on the rise because there's automated toolkits that make this easy at scale. And it's a lesson that we really should have learned a couple years ago. For those of you who remember, a couple years ago, there was this huge iCloud fiasco where a whole bunch of famous actresses and stuff like that were getting their iCloud photos breached. And when it was dug into, in reality, what it was not so much that their accounts had been compromised because of Apple insecurity. Their accounts were getting compromised because they had reused usernames and passwords on other sites that were then being used to access their accounts. And so that's unfortunate, should never have happened, but is a lesson that, you know, we kind of should have learned a couple years ago. And today we're seeing breaches on O365, on G Suite, on AWS that are taking advantage of the same kind of credential stuffing attack. One thing you can do that's going to immediately have an impact is enforcing MFA usage. Again, on your cloud environments, on your email environments, on any sort of critical document repositories or code repositories. Even if you have the credential, you then need the second token. We're a big fan of authenticator apps. We use 1Password ourselves, which is really strong, but there's other tools like YubiKey, which is a physical token. SMS is better than nothing, but you should never ever use SMS for password recovery. So SaaS environments can be more secure, but you as a user are still responsible for making sure that your credentials are secure. And so making sure that you're not reusing passwords and that you protect yourself against credential stuffing attacks is really important. So that's my last war story. And with that, I'm kind of summarize our key recommendations from today's talk. So the first, obviously, is understanding your responsibilities in the shared responsibility matrix, whether that's as an IaaS, a PaaS, or a SaaS customer. Being very careful and on permissions and credentials, auditing these and scanning these regularly so that if you have permissions creep or credential misuse, you're able to detect it early before it leads to a compromise. Invest in your developers, especially if you're building cloud environments. You know, your developers are human too. We all make mistakes. It's normal. but investing in them so they understand best practices and they're being kept current as it relates to security best practices is very, very important. And then lastly, using multi-factor authentication where you can, and monitoring so that if something gets past all these other layers, that you're able to see when something goes wrong before it gets too bad to secure your services and detect issues. So those are our summarized findings. And just a little bit about Cobalt as we're wrapping up. Cobalt helps small and mid-sized organizations assess, develop, and run their cybersecurity programs. And we can help you in a variety of ways. And specifically as it relates to today's talk, we can help you with security architecture. So that's designing your cloud infrastructure, making sure it's secure, making sure you're doing your IAM properly. We can do cloud security assessments on your behalf, technical security testing like pen tests and stuff like that. We can help your development team learn about software development best practices, and we can provide ongoing security monitoring services to help secure your infrastructure as a whole. And we also can wrap up all of these things, a number of these things, into security programs as a service so that you have a complete security offering. So that's Cobalt in a nutshell. If you'd like to attend future webinars, you can subscribe to our mailing list to receive updates and invitations to future events. And if you'd like any assistance with your security program, you can contact us in all of the usual online ways, and you can see the details there below. So with that, I will stop my presentation and see if there are any questions from the audience. And I'm going to stop that. And does anybody have anything they'd like to ask before we wrap up? How do we do the SDLC training? That's a great, we have a couple different options. So one of the options is we can do this online. So that's based on the software developers kind of availability and time, they can go to an online program, they can go through it and kind of access this as needed. We can also do virtual or in classroom sessions where we bring together a group of people. That's very good, for example, if you're trying to bring your entire team up to a certain baseline. And we can also recommend specific resources like books and other things for your team to read that can really help them develop. If you're interested in SDLC training for your team, please get in touch. We'd love to you. Earlier, you can deal with security problems in your design and development cycle, the less costly they are for you in the long run. So less effort in terms of remediation or, God forbid, a breach actually occurring. Any other questions? All right. Thank you so much for attending today. Hopefully you found it useful, and really appreciate your time. Since it's December, I wish you all a happy holiday season. Stay safe, stay healthy, stay secure, and we look forward to seeing you at our next webinar.